kids, Miss Kulkarni here. So are you ready for some rate law calculations? Let's begin. In this table, there are different concentrations for A and B are given, and with respect to those concentration, the rates of reaction are given. And our job is to find out the order of the reaction with respect to A and then B and some more things. Let's see how can we find out. Let's start actually labeling each one of those as T1, T2, trial 3, 4 and 5th. Now your job is to find out two readings for which the concentration for B is same. And there you go. The first two readings show that B is exactly 0.05. Let's write down now T2 with respect to that. T2 is the rate, which is 1.865 times 10 to negative 3. And that will be equal to K, the rate law constant, times A. A is 0.10 to the power X, if X is the order of the reaction. And it is the concentration for B, which is 0.05 to the power Y. And trial 1 will give you the answer 4.66 times 10 to negative 4 is equal to K. And now the B and A are different. So with respect to A, that will be 0.05 to the power X and 0.05 to the power Y. And now we are going to actually divide those two equations. When we divide, K gets cancelled. Keep in mind, this is the same exponent for these two numbers. So we can actually combine those. When you solve these two, when you divide those, you are getting 4.002. And when you divide these two, it is 2 to the power X. And this gets cancelled. So 2 to the power X equal to 4. What should be X? X should be equal to 2. 2 square is equal to 4. So what did we get? We got the order with respect to X, with respect to A as 2. In the next question now, we are finding out the order with respect to B. At this point, we are going to find out two readings when A is constant for both of the trials, and those are trial 5 and trial 4. So let's put the equation there and find out what do we get. We end up getting 8 is equal to 2 to the power Y. So that makes Y is equal to 3. 2 cube is equal to 8. Let's calculate the temperature independent rate law. This is without having the value for K. So we are going to make use of the order of the reaction which we found out by our calculations. So that's constant K. And with respect to A, the order we found was 2. With respect to B, it was 3. And that's it. That is the temperature independent rate law. Now how do we find out the rate constant K? For that, we select any equation and we plug the value of everything except the K, which is unknown. So let's do this. Let's begin with the row number 1. So this is what we get if we plug in the values using the row number 1. And now when we solve for K, what do we get? We end up getting the answer 1491. The units for K are unique. They are different. It's always the time to the power 1. Now, the time in this table is given as seconds, so it will be seconds to negative 1. And its molarity, and the power from molarity is the overall order minus 1. The overall order in this case is 2 plus 3, which is 5. And from that, we subtract 1, so that is equal to 4. So this is m to the power 4. Those are the units which we are getting for K. Little weird, right? Okay, now last thing is using the value for k, we write down the rate law equation. So what do we have? A rate is equal to, instead of k now, we put the value 1491, and then it is a to the power 2 and b to the power 3, because these 2 and 3 were the orders of the reaction which we found earlier. I hope you enjoyed the video. I will see you in next video. Until then, bye bye.